So this is the other sheet that we had for homework tonight. So on the front of this page we see an experiment done to the fullest with data set up. We have the mass of AlCuCl2, the beaker with water, the mass of beaker, copper with the filter, and the mass of the filter. Now if we go to the back of the page, the part that we're supposed to fill out, what we see is the first part. For the moles of aluminum, we're going to have to figure out what the moles of aluminum are for experiments 1, 2, and 3. So going back to the data for experiments 1, 2, and 3, we have the mass of aluminum. So here what we're going to do is convert the mass of aluminum to the moles of aluminum. In order to do that, we need to use the molar mass. So for every 26.98 grams, there are 1 mole of aluminum. And that 26.98 grams is of aluminum, and I got that from the element chart. So for every 26.98 grams, there are 1 mole. What we have here is 0.25 grams. So this would be 0.25 grams. And in that case, we would be dividing. And if you figure out the conversion factor from 26.98 to 0.25, what you would find is that we would have to divide by 107.92. So we would do the same we would do the same thing for the moles of aluminum. Divide by 107.92, and what we get is a mole of 0.009. So for the moles of aluminum for experiment 1, we have 0.009. For experiment 2, we started with 0.5 grams of aluminum, and the answer should be, using the same method, 0.018 moles. And for experiment number 3, we should have from 0.75 grams converted to 0.027 moles of aluminum. So the next part is finding the mass of copper. In order to find the mass of copper, what we're going to have to do is go back to the data table and see that we have mass of copper plus the filter paper here in this row. And this is experiment 1, 2, and 3. But here we have the mass of the filter paper. So if we subtract the filter paper mass from the mass of the copper and the filter paper, what we would be able to get is the mass of the copper alone. So 1.70 minus 0.9, this should give us the mass of copper as being 0.8. And if you do that going through the entire table, what you would find for the mass of copper should be 0.8 grams, 1.8 grams, and 2.64 grams. So now what we have is the mass of copper. So in order to convert from the mass of copper to the moles of copper, we're going to need another for every statement. For every 63.55 grams, which is the weight of a copper from the periodic table of elements, there are 1 mole of copper. But in this case, for experiment 1, we have 0.8 grams. So we have to find the conversion factor there, and it would be 79.44. If we do 1 divided by 79.44, likewise, we would find that the moles is 0.012. And you would go through experiment 2, and instead of putting 0.8 grams here, you would put 1.8 grams and find the conversion factor, and do that likewise. So the answers for the moles of copper are 0.12, 1.8, I take that back, 0.028 and 0.041. So the next step for the homework is to fill out the table and graph the moles of aluminum, this being the independent variable, which means that it would be the x-axis, versus the moles of copper, and then to find the slope. So first thing, let's graph it out. So here we have moles of copper, and here we have moles of Al. So let's try to make the best estimate that we can. So for the X, which would be the moles of aluminum, we can think of this as 0, 110, this as 0, 2, 0, this is 0, 3, and this is 0, 4. And on the y-axis, with the moles of copper, we can think of this as 0, 0.01, 0.02, 0.03, and 0.04. So that should help us out in plotting this graph. So I already have the first two data points plotted. So the x-axis we have 0.027, which might be somewhere around here, going up to 0.041, which might be somewhere around here. So we can sort of draw a best fit line, kind of. Now, the line isn't as important as finding the slope. So we have three different points here. I'm going to label a couple of them. So I've labeled the first 2 points in coordinates. I have the x and the y, and I have the x and the y. And these are the numbers that I got from the table itself. So in order to find slope, which is m, that is the change in y over change in x, or rise over run. So this would be 0.028 minus 0.012 divided by 0.018 minus 0.009. This should end up being 0.016 divided by 0.009, which should be 1.7 repeating. So that is the slope that we got for this graph. And that is the relationship between moles of copper and moles of aluminum. So why is this number 1.7 for slope important to us? Well, it's important to see whether we got a relationship that resembles what we have from the balanced equation. So the balanced equation for this experiment is as follows. And when comparing aluminum to copper, y over x, we look at the coefficients. And what we get is 3 over 2, which is equal to 1.5, which is roughly the slope that we got from this experiment. So that means the experiment that we ran was relatively close to the experiment as predicted by the balanced reaction.